Hello again, it's me. Hope you guys have been having a good day. Hopefully you've been doing your homework, staying inside, being safe. When it comes to the extra credit questions, I will be answering them all on Monday. So you actually have until Friday of each week to answer any of the extra credit questions. Am I going to have an extra credit question every time? I don't know. Is it going to be about each lesson? I have no idea. I'm just going to randomly come up with extra credit questions. So just stay tuned and keep posted and keep sending those answers in. Here we go. 10-4 is about zero exponents and negative exponents. And I wrote I say powers, but it's properties, all out for you. Okay, so 10-4. Here we go. Zero exponent. It says, for any non-zero number A, so basically anything but zero, if you raise it to the zero power, you're going to get 1. But remember, A cannot equal 0. And here are the words. Any non-zero number A and A to the 0 is undefined. You can't do it, okay? And then your negative exponent. For any integer n, remember integers are positives and negatives, no fractions and decimals, and 0, okay? A to the negative n is equal to 1 over A to the n, which means that A, again, cannot be 0. More words on the bottom. For any integer n, and any non-zero number A to the negative n, where is it? There we go, is actually the reciprocal of A to the n. All right? And I do have pictures of the properties, and I will post them after I'm done. Here we go. So example 1. We're going to evaluate. Let me get situated here. All right, evaluate. So we have 3 to the negative 4th. So remember, evaluate 3 words. Do the math. So remember, it could be calculations, it could be simplifying, it could be a lot of different things. So just make sure that you just do the math, whatever it's asking, whether it's order of operations or not. All right, so 3 to the negative 4th. First thing I do is I am going to put this over 1, and then you're going to flip it. So it becomes 1 over 3 to the 4th. Okay, so negative exponents do not mean negative answers. They mean change location. So if it's a negative exponent on top, it ends up positive on the bottom. If you have a negative exponent on the bottom, it becomes positive on top. So it'll just flip, and then the power will become positive. And then, can you do more with this? Yes, you can. So it's 1 over 3 times 3 times 3 times 3. So that's, group of 9, another group of 9. So 1 over 81. So negative exponents, nothing negative about it in the answer. That just means the number becomes smaller. It actually becomes a fraction. And we're going to be doing a few of those. So today you're going to start to see more of the properties become involved with the problems. And on this next one, I'm going to do it next to it. You have the quantity negative 8.5 to the negative 4th times the quantity negative 8.5 to the 4th. And I'm just doing example 1b. There are so many different ways you can attack exponent problems, guys, and it really doesn't matter, but I always kind of stick to the same thing. So we're not jumping straight to a negative exponent problem. We're going to look here, see what this problem is, and the base is the same. And since the base is the same, then you can add your exponents. So you have the quantity negative 8.5. Don't forget to keep the parentheses. To the negative 4 plus 4. And so you get the quantity negative 8.5 to the 0 power. Well, your 0 property told you that anything raised to the 0 power is 1. And I'm going to show you why here in a minute. Okay? If I raised x to the 1, x to the 0, it's going to be 1. If I raised 5 to the 0, it's going to be 1. If I raised pencil to the 0, it's going to be 1. If I raised Johnny to the 0 power, it's going to be 1. If I raised chocolate chip cookie to the 0 power, it's still going to be 1. We're going to do another one, and then I'm going to show you why something to the 0 power is 1, because you guys may have known that answer, but when I ask kids, how do you know that? No one's ever able to explain to me how they know it, so I'm going to show you. Next problem. 2 to the 6th power over 2 to the 8th. All right. So, is the base the same? Yes, it is. So now, since it's a division problem, we're using the property from yesterday. So we have 2 to the 6. What do we do with our exponents? Subtract. So we have 2 to the 6 minus 8. So we have 2 to the negative second power. But you can't leave it like this. You can never, ever leave anything with a negative exponent. It's like leaving your answer as 2/4. It's just not simplified, and it's not good math practice. So, since it's raised to a negative power, kind of like this first problem, we're going to throw it over 1 and then flip it. So then you have 1 over, and when you flip it, your power becomes positive. So you have 1 over 2 squared, and now you're going to do 2 squared, which becomes 1 over 4. And that is your final answer. But you can expand this. Watch this one. You're going to like this. And I didn't do it with this one. I didn't do it with that one right there, but I'm going to do it with this one. You guys are going to like this. So on negative exponents, some of you guys will probably end up preferring to expand it because it ends up becoming faster. And then you don't have to worry about the whole reciprocal and flipping it. And, you know, when does my power become 0? When does it become positive? When can I add exponents? When can I subtract exponents? You don't have to worry about any of that. So watch this expanded. How many 2's do we have on top? 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. How many do we have on the bottom? 8. 5, 6, 7, 8. Okay. And do the 1-for-1 simplification. So 2 divided by 2 is 1, but you don't need to put those ones there. And you keep doing it until you run out of 2's. And you ran out of them on the bottom. So when you do your answer, what do you have on top? Some of you guys are going to say zeros, but it's not a 0. Remember, you have all these 1s. So 1 times 1 times 1 times 1, as many times as you want, is still going to be 1. Over 2 times 2, 4. And so that answer actually gets you there faster when you expand this, when you have a power on top that's smaller than the power on the bottom. So on today's homework, if you would rather just expand it and not have to worry about all this, that's totally fine. I told you guys you never ever have to memorize any of the properties. I kind of like this one for negative exponents. Okay. I did it again. By the way, some of you guys were really, really close on how many times I say okay or K or something like that. But now I'm going to show you why something to the 0 power is 1. A number, 4. Okay, so if we have 4 to the second power, and I asked you guys to expand that, most of you guys would say 4 times 4, which, you know, that's pretty good. But then, if I asked you to do 4 to the third power, you'd go, okay, Ms. Parks, 4 times 4 times 4. Looks pretty good. But if I asked you to expand 4 to the first power, most of you guys would just put 4. But here's the thing, remember, exponents is repeated multiplication, so you actually have to expand 4 to the first as a multiplication problem. So what would you multiply 4 by to show that it's a multiplication problem? 1. So it actually is 1 times 4. So 4 squared is technically a power of 4 to the first in it, so there's 4 to the first, and then there's 4 to the second. So 4 to the third has 4 to the first, 4 to the second, and 4 to the third. And so if I do this with 4 to the fourth, it's 4 to the first, 4 to the second, 4 to the third, 4 to the fourth. So 4 to the fourth tells you there's 4 4's being multiplied. 4 to the third tells you there's 3 4's being multiplied. 2 and 1. So if we have 4 to the 0, if you follow that same pattern, what is being raised to the 0 is 4. And if you follow this, how many 4's are being multiplied? Well, there's going to be 0 4's in here, but what is still left? You still have that factor of 1. So here it's 1 4 being multiplied, 2 4's being multiplied, 3 4's being multiplied, but up here there's 0 4's being multiplied, but you still have that factor of 1. And that's why something to the 0 power is always 1. So table to the first power is 1, because table to the first power is 1 times table. So this works with anything. And this is why something to the 0 power is 1. So if anyone ever asks you to show them, you now may do so. I kind of like that one. I also have another activity to do with folding a piece of paper. And if we were all in class, I would show that to you. Maybe for our Zoom meeting next week that we could do that. I'm going to have weekly check-in videos with you guys to make sure you guys are doing okay on stuff. All right. I'm going to do some more examples. So if we have, and this is still example 1. I put that in kind of the wrong order. So if we have 4 to the 5th times 4 to the negative 3rd over 4 to the 2nd. So what we're going to do is do not do that as a negative exponent first. We are just going to use properties that we've already learned. So you're going to start to see all your product properties, the 3 of them, and you're going to see your quotient property and the 0 property and the negative exponent property all in today's lesson. So here we go. I am going to simplify this top piece right here. 4 to the 5 times 4 to the negative 3rd. And so our base is the same. And so what do you do when your base is the same and it's a multiplication problem? You add these exponents. So you have 5, I hate doing this, plus a negative 3. You guys know I don't do plus minus. You guys were taught to subtract. But that's really what it is. Over 4 to the 2nd. So 5 minus 3. So you have 4 to the 2nd over 4 to the 2nd. Now, is the base the same still? Yes, it is, but now it becomes a division problem. So now we are going to subtract. 4 to the 2 minus 2 is 4 to the 0, and that's kind of coincidental. I just did that. Did not mean to do that. And 4 to the 0, we just did that, is 1. Can you expand this? Yes. I am going to show you guys that part later. It can get a little tricky just because there are so many ways you can attack these problems. So I'm going to expand it, but I'm going to show you after I kind of get through some more problems, so that way you can have a little bit more experience, even in the short amount of time, to work on some of these. All right, so example 2 is simplifying. So now remember, simplifying means do until you can't do any more. So that's what you got to ask yourself when you're on these problems. Can I do more? No. Okay, then you're done. Can you do more? Yes. As in you can multiply, so then continue doing that. So just keep asking yourself, can I do more on these problems? Here we go. Negative 5x to the 0 power. And on this problem, you have to ask yourself, what is being raised to the 0 power? And remember my video from yesterday, if you guys have been watching that, I caught some of you guys to say you have been, but you haven't. Remember, the power is going to hug whatever is directly to its left, and that is what's being raised. So in this problem, negative 5 is not being raised to the 0 power, just x is. All right? So when we simplify this, we're going to do x to the 0 power. Well, I just showed you guys the trick that anything to the 0 power is going to be 1. So it's negative 5 times 1. And we're simplifying, so can I do anything more with this? Yes, you can. So negative 5 times 1, negative 5. And you're done on that one. And I finally figured out where that glare is. That is my computer screen right now. Here we go. Next one. 9y to the negative 3rd over y to the 5th. Ask yourself, what is being raised to the negative 3rd power? Hopefully you said just y and not 9. If they wanted 9 and y being raised to that negative 3rd power, they'd put it in parentheses, but they didn't. So remember, that power up on the left-hand side is... Am I doing this the right way so you guys can see it? I'm so used to doing it so you guys can see it. Whatever's up here is going directly here to this power, not this stuff here. So if I had one of you guys stand next to me here, this power would belong to me, but not you over here. I hope that made sense. Okay. Here we go. All right, so we are not going to do anything with this 9. That is going to stay on top. But you can do this. And since it's a division problem and the base is the same, you're going to go 9y to the negative 3. And remember, you subtract your exponents, minus 5. So you have 9y to the 3 negatives and 5 more negatives, get you negative 8. But that is not simplified. Remember, you cannot leave anything with a negative exponent in your answer. You must take the reciprocal of this. So you're going to put this part over 1. Flip this. 9 stays the same and it's on top. How do I know it's on top? Well, what can you throw that 9 over? A 1. That's how I know it stays on top. So it becomes 9 over, and this gets changed. Why? The power becomes positive. Y to the 8th. And ask yourself, can you do anything more? Nope, you can't. You're done. So one's a little bit trickier. And these are going to get trickier because you have all these properties that you have learned this week, and you're going to start to include them. When you get in algebra, you are going to actually learn 2 more properties. Two more. I had to think about that. 2 more properties that you'll learn. So you're not quite done with exponents in Math 8. You're going to use them quite a bit more. Okay, here we go. B to the 0. You should know what that is by now. I wonder what that is. Times b to the negative 10. Couple ways you can do this. Yes, you can go b to the 0 as 1 times b to the negative 10. Or I do it the same way every time. If the base the same, yes it is. So b to the 0 plus negative 10. Ugh. I'm going to get rid of that plus minus because you know me, I don't like those. Becomes minus. And it's b to the negative 10, which is still the same, but I like to do things the same way. But you can't leave something with the negative exponent, so you're going to put this over 1 and flip it. So when you take the reciprocal and you flip these things, your power becomes positive on the bottom. So remember, what's negative on top ends up positive on the bottom. What's negative on the bottom becomes positive on top. So it flips, and the power becomes positive. Equals 1 over b to the 10th. And since this is no longer negative, you're good to go. What do you guys think about these so far? They're a little bit trickier than you guys have been used to. I will say that. And looking at your homework, there's just a lot of variety in these type of problems. Whether it's, and here's one they didn't even do as an example. There's a lot of variety in how many different properties you can use, how well can you expand it, can you expand it? Yes, of course, you can expand everything, but I haven't shown you everything just yet on how to expand some of these. Here's a problem. I'm going to change this. Here's a problem they have in the book, and of course they don't have examples on this. So you have 3d to the negative 4 power times 4d to the 8th, and this is like your homework, but I changed that exponent. So what you're going to do before you do anything with your negative exponents, separate these out because this is one of the most common mistakes kids will make, and they will forget to multiply this. So I group these up times d to the negative 4 times d to the 8. So that way I don't forget to multiply 3 times 4. So I have 12. I took care of that now, and now I can work with these guys. And since the base is the same, you're going to add your exponents. So it becomes d to the negative 4 plus 8. And so you have 12d to the 4 negatives and 8 positives. 4 positives. And you're done. You can't do anything more with that. So make sure if you see something like this, where things are being multiplied, pull apart your coefficients and group them together. When I say group them, you're going to put those in parentheses. Another way of saying parentheses is grouping symbols. I know it's probably been a long time since you guys have heard that one, or maybe it's just a quick reminder. But yeah, I group those together to make sure that I don't forget that part, because that is one of your most common mistakes that kids will make. All right, now I'm going to show you this expansion. And I'm kind of worried. I don't know if I really should show you expanding on all this, because it might really confuse some of you guys, and some of you guys will be like, oh, I got this. I'm going to do this from here on out. But I'm going to do it because I think it's important. All right. Oh, I'm trying to find good problems. And I still haven't assigned homework yet on purpose. Okay, here we go. 3 to the negative 3 times 3 to the negative 2. I'm going to show you this expanded. So when you expand negative exponents, what you're going to do is you're going to change its location first. So since it's negative and you know that they end up on the bottom, what I'm going to do is I'm going to put 1 over 3, and remember this power becomes positive, times 3 times 3. I already switched it. Times, I'm going to flip this again, 1 over, how many 2's? Sorry, how many 3's? There's 2 of them. 3 times 3. And then you have 1 over 3 times 3 times 3 times 3 times 3. Oh boy, I didn't bring my calculator. So there's 9. There's another group of 9. 81. So what's 81 times 3? 20. Is that 24? Yes. So it becomes 1 over 243. So I'm going to write this. Negative exponents, and I will take a picture of this. I know I keep saying that on some of them, and I'll say, yeah, I'll take a picture. And then next thing you know, you see me erasing it. I'm really sorry about that. Negative exponents do not mean negative answers. It means ... change location. And so those of you guys who are taking notes, that would be blue. That's super important to remember. And yes, I will take a picture. And yes, I will send it to you. Negative exponents do not mean negative answers. It means to change location. All right, now that I'm already over at 22 minutes, I'm going to cut off right now. And if you guys need help, remember, do not hesitate to contact me. I am possibly considering doing homework different again. Post videos, make sure you watch them, and then post homework. I might, have 2 homeworks due on Wednesday and then 2 more due on Friday. I don't know. I'm keeping it changing because some of you guys will do all your homework in one day, and then some of you guys will leave it all till the very end of the week. And so I just want to make sure you guys are pacing yourself, especially now that I'm doing videos all the time. So I hope you guys are having a great day. I hope this helped. I do have an extra credit question of the day. And you can answer this up to next Friday. This is a Friday, but I'm going to post this until later. But you don't know that. I don't even know why I said that. Your extra credit question of the day. What was the opening year of Haunted Mansion at Disneyland Park? Have a great weekend. Bye, guys.